Before we start this video, a large thank you to Alexandros, Yowart, Justin, and Brad for their support on Patreon. I hope you guys enjoy the video. And a massive thank you to Halo Burner, Ryan Belland, and Fernando for their immense support to the channel this month on Patreon. I hope you guys enjoy the video. Hello everybody, so today we're going to go and continue with our movement system, and we're going to start by opening up the player locomotion manager because we're going to make it so that when we're moving or on the way to a destination, we're going to trigger our animations by changing that flag on the animator is moving to true. So let's say using system collections, and then we're going to say private I enumerator down here right below move player to position, and we're going to say movement coroutine. I'm probably going to change the name of that because that's a bit ambiguous, but we'll come back to that in a second. So I'm going to make a private coroutine variable. I'm doing this so we can start this coroutine using this variable and then stop it so we don't accidentally run the coroutine twice. So under move player to position, we want to just say if movement coroutine does not equal null, stop coroutine, movement coroutine. And then we're going to say movement coroutine is equal to start coroutine, and we pass the function we just created called movement coroutine. Now I'm thinking I'm definitely going to change the name of that because that is a little too ambiguous. So we're going to start by saying while, and we're going to reference the player.navmesh agent. And if we're going to say here, if it's path pending, which means it's calculating a path, we want to wait. So we're going to say yield return null. So we'll just keep looping until it's done. We don't want to do anything until the path has finished calculating. So I'm going to make a comment here while the path of the navmesh agent is still being calculated. Just wait. And then we're going to right click here. I'm going to change the name, and I'm going to call this has reached destination coroutine, because what we're going to do is flip the is moving to false when we're done. So let's make a comment here. The pseudocode is moving is equal to true. We don't have a flag for that yet, but just pretend like we do, and we'll come back to it and make it when we're done. So we're going to start the movement coroutine, and we're going to say is moving is true. And then while the path is still being calculated, wait. If the path is done calculating, move on, and we're going to say if the remaining distance on the navmesh agent is greater than the stopping distance, that's the distance you're going to wait before you stop to get to the point, then wait again. Otherwise, moving is false because we've arrived. Okay, so we have this basic setup here now. Let's go over to the player prefab, and I'm going to add a component, a new script called player network manager. So I'm just going to create and add that. And I'm going to open it up and delete the start and update functionality as is per tradition, drop in my namespace. And the first thing we're going to do is make this derive from network behavior. So what we want to do now is make a flag for is moving. And for those of you asking why is this a network variable, which is what we're going to do, it's because if I'm playing a game with you and I tell my character to move, then you have to know on your end that my character is moving so you can change the animator and start playing the walking animations. So I'm going to make a header called network flags. We'll make a public network variable of type bool is moving, and we're going to set it to new, defaultly at false. And then the read permissions is going to be everybody, and the write permissions is going to be the owner. So basically the idea is when on my end I move, I'm going to change this flag to true, and then on your end it's going to be true for you as well because it's a network variable. And then from there we can update the animator to whatever this is. So to do that, let's make a public void on is moving changed. Make it require a bool of old status and bool new status because we need to do that when we subscribe to the on change event. And now let's make a local player, let's make a player manager variable here. On awake, say player is equal to get component player manager. And then what we're going to do is say player, and I see we don't have a reference to our animators. Let's go do that. All right, hop into the player manager and make a reference to your animator. So I'm going to hide an inspector because we don't need to see it. Public animator, and I'll just say animator, and then on awake I'm going to say animator is equal to get component animator because it's on the same game object as this. So from there we can literally just take this now and set the bool in the animator, and we're going to set it to whatever that network variable is. So we'll say player.animator set bool, and make sure you spell it right, it's case sensitive. Is moving, and we're going to pass whatever is moving is. So this is going to change the is moving bool here to whatever we have is moving as a network flag. Now you can just double click here and copy and paste it if you want to make sure you spelled it right under parameters. But now we need to call this. So over on the player manager on network spawn, make sure you're not checking for ownership here because this has to be called on both my end as the owner of the object and my character model in your game or my character object in your game. So you can update my character's animator when I'm moving it from my end. So we're going to say player network manager is equal to get component player network manager. And then we're going to say player network manager dot is moving dot on value changed plus equals player network manager on moving changed. So this is just going to basically subscribe to this, and whenever it actually changes its value, it's going to call this function, and this function is then going to update the animator. So just so there's no memory leaks, make sure you call override on network despawn, and likewise you unsubscribe from this event. So copy it and paste it down here and replace the plus with a minus, and then you're good to go. Okay, now let's save that. And now let's go over into the player locomotion manager, and now we can set this flag right here, is moving is equal to true. We'll say player network manager is moving value is equal to true. And then we're going to do the same thing down here, but set it to false. And actually make sure you set the is moving flag to true first, then run this, because there could be a situation where you instantly set it to false. So set it to true first, and then run the coroutine, and then when it passes all the checks, then it will go to false. Alright, save that. Now if I come in the game here now, you can see, yep, we are playing some animations. But you see how there's like that weird floatiness to it? Well, that's for a couple of reasons. One, the navmesh agent speed doesn't match our character speed. And two, the navmesh acceleration is a bit different when it breaks. I'm just going to put a cube here real quick too and bake this in the world scene. I think it will just find the closest path to the edge, but I just want to make sure. So I'm going to do that real quick and test that with you real fast right now. So we're going to save that. You don't need to do this because I'll get the answer right now. And if I click over here, it should stop at the edge. And yes, it does. Okay, cool. All right, so now let's talk about the floatiness again. Now, I know the actual speed of the walking animations I'm using because I have the animation files. So I could go down here right now and go to my navmesh agent and change the speed from 3.5 to, say, 1.3. And then if I click, you see, it syncs up perfectly. But when I get to the end, there's still a little bit of trembling, that floating that's happening. So there's a way you can deal with that. There is a setting on the navmesh agent called auto braking, and if you disable that, it won't do that floaty thing. But there's a chance too it can overshoot the position just a little bit, which isn't a big deal in my opinion. But kind of play around and see what you want it to feel like. Also increase the angular speed to a high number if you want rotations to be nearly instant. So this just comes down to how you want the game to feel. Like play around these settings and experiment and see what different things do. But this right now looks a little silly to me, so I'm gonna go over here and untick auto braking, and then watch. I'll show you again. If I click here, see that? We stop. But if you don't like this, then there's a second option, although I think this is fine personally right now. And the second option is to move the character with the animations themselves. And I'll show you how to do that. So come down here and create an empty game object called navmesh agent, and then copy your navmesh agent component here and paste it down here, and then delete the one on the parent object. And then let's just remove this like so. All right, now let's save the prefab, go to the player locomotion manager, and I'm going to make some functionality that only needs to be called if you're doing it this way. So I'll make a comment, use this if you desire to move the character with root motion. That's the animations movement itself. So basically all the movement will be done with animations. This includes too, if you ever had like an attack that moves your character, you could do it this way as well. So I'll make a private void called sync character with agent, and we're going to use the agent to determine what way we're going to rotate so we can use its AI to actually get our path, but we're not going to move with the agent's movement. So first, let's get a position difference here. I'm going to say this is going to be the navmesh agent's transform.position minus our transform.position. You could say transform.position or player.transform.position. It's the same thing as long as you have them on the same game object. I'm just going to say player because I think that reads nicer. And then we're going to say if position difference.magnitude is greater than 0.2, we're going to basically reset the navmesh agent to its local position. And actually thinking about this now, I think we can just reset this to 0 after we copy the rotation, because I'm kind of ripping this a little bit from my project here, but my project is a little different. So let me just circle back to this in a moment, but for now we'll go with this. So we can make a private float here called max navmesh agent, what am I going to call this, magnitude difference, and we'll say 0.2 because magic numbers are generally not encouraged. So let's copy this and use this right here. But basically this makes it so if the navmesh agent gets too far away from underneath our player, because it's going to try to move, this will reset its position to 0, okay? And then we're going to say, if the player, we want to check if we're moving, so we're going to say player network manager is moving. What we want to do is simply copy the rotation value exactly of the navmesh agent. So we're going to say player.transform.rotation equals player.navmesh agent.transform.rotation. Okay, so if we save that, and then we're going to come down here, and I'm just going to call this. Let's make another function here, because in the future, I'm sure we'll have more locomotion logic. So I'm gonna make a public void handle movement. And this is just one piece of the movement. We might only have a couple of pieces, but we can kind of put them in their own separate functions. And then on the player manager, on update, I'm gonna call handle movement from the player locomotion manager. And if you can't tell right now, the player manager is where I'm handling all update functionality, and it connects all the components together. Okay, so I'm gonna say if we're not the owner, return, or rather, if we are the owner, run this logic. Either is fine. Now, tick apply root motion on your animator, like so, and then save your prefab. And let's go and see what happens. So there's that really weird wobble, and that's happening for a few reasons. Well, first off, you want to give some stopping distance to the character. Then we want to save that prefab and go back into our player locomotion manager. And what we want to do is, and honestly, I don't really need this magnitude check now I'm thinking about it, because all I really need to do is, after I rotate my character towards the agent, immediately after, I want to set the agent's local position to vector 3.0 and its local transform to quaternion.identity. And this is because basically if I don't reset it, you're going to consistently snap back and forth because you're moving the agent's rotation when you rotate the player. So after we've copied the agent's rotation initially, instantly just reset the transform and the local position and the rotation. And there we go. We don't have that crazy wobble anymore, and that looks really good. So just to show you too, if I go to the animator here and I go to vertical and change it to 1, remember that's how we run. You can see here, that looks nice. It's stopping at an appropriate place. The rotation is pretty great. So if you want to adjust the rotation speed, you can see mine's on 1,000, the angular speed. You want to crank that up pretty high because we're basically setting the character's rotation speed to whatever the navmesh agent is instantly. So the rotation speed here will be determined by the navmesh agent. Now, one last thing. We can't really test this right now because we don't have any connected clients, and we don't have a setup to actually load in a second player. Not easily anyway. But let's go ahead and make network variables for our position and our rotation anyway, so we can basically set this up for when we do test in the future, so our position and rotation will be synced. So let's make a header for position under player network manager, and I'm going to make a network variable called, it's going to be a vector 3 called network position, and defaultly it will be at vector 3.0. The read and write permissions will be the same as before, everyone an owner, and then do the same thing for a rotation, but it will be a quaternion variable. So basically, here's how it's going to go down. If we're the owner of the object, so you're the controller, if it's your player object, you're going to move around on the map, and then you're going to reflect that and update your position to the network position and network rotation. So if you move to world space 111, then you're going to tell the network position variable, hey, I'm in world space 111. And then on your end, my game object, let's pretend I was in your game, is going to move to position 111 because here on the update functionality, we're going to say if we are the owner, handle movement. Otherwise, we're just going to simply copy the position of the network position and the rotation of the network rotation. Now, if you just said transform.position and transform.rotation equal whatever, you're going to get some stutteriness. It's not going to look very nice. So what we got to do is kind of like slurp between those two. So let's go back and add a flow for network smooth time. And then we'll add a public vector 3 for network position velocity. So network smooth time 0.1. That's a pretty good time setting, I find. It's nice. It's quick enough where it updates very fast, but you still get a nice smooth effect, so it's not stuttering. Now, for position, we're going to simply say transform.position is equal to, and we can use a vector 3 smooth damp here. And if you're not used to using smooth damps, take a look at the documentation, watch a short video breakdown on it. We're going to pass the transform.position, and then we're going to pass the desired position, being our network position value. Then we're going to reference our player network manager network position velocity, and finally the smooth time by saying player network manager smooth time or network smooth time. And that is our position. Now for our rotation, we're going to do something a little bit different, but still going to use the smooth time variable. We're going to say network or transform.rotation rather. Let's comment this out first, just like above, or you can delete it, honestly. Transform.rotation is equal to quaternion. Oh, I did not mean to say root. It's supposed to be rotation. Transform.rotation is equal to quaternion.slurp. I don't know why I'm trying to type smooth. There we go. And then we're going to pass our current rotation. So transform.rotation. And then we're going to pass the desired rotation, which again is the network rotation. And then we're going to pass the time, which in our case is going to be time.delta time divided by our network smooth time. And that's basically it. Now, if you don't want to use either of these, what you can also do is, I'm just going to save this and show you. You can go to your player prefab and you can add what's called a network transform component. I don't use these in my games, but basically this will auto-sync the transform of the object for you, and there's some settings you can look into. If you're going to use this, take a look at the documentation on it. It's pretty handy. But this is a tutorial series, so I figured I would show you how to do things manually as well, obviously. Okay, that's it for this video, guys. Now you have two methods of movement. So I have a question for you now, and this is important to voice what you'd like to see in this series, because this series obviously is for you guys, and I will showcase whatever you want me to. Do you want me to show WASD movement as well in the next video, or should I move on and go to a different topic, or basically refine one of these movement systems and start working on the camera? It's up to you. I'm okay with showcasing whatever you'd prefer to see. My goal with the series is just to give you a bunch of different tools and ways to approach the development of your project. So a fun thing to try now is you have all of this movement tech. So why don't you go ahead and try to set up a basic camera system. The camera doesn't have to move, but it does have to follow the player's position in the world. So a fun exercise would be to determine the best way to go about that. And depending on what you guys say in the comments of this video, I will either move on to something else, or I can showcase some WASD movement, or we can kind of go into a refinement of this movement system a bit more. Okay, everybody, thank you very much for watching. I hope you all have a very lovely week. Thank you to my patrons for keeping all my series alive. Thank you to the people who take the time to leave a like and comment in the video and share the series via word of mouth. You all have my sincerest appreciation. I will see you in the next one.